Okay, this help video is designed to help you correct pressure transducers such as a Schlumberger level logger or barrel logger to the actual depth below ground surface or the in measurement of your well. The first thing you'll need to do is get your data into Excel. You'll note over here that this file originally had a .mon, M-O-N, or a monitoring file extension, which if you double click probably won't do much. So you might need to change it to a .txt or a .text file, or you can probably try just dragging the .mon file into Excel. Once you have it in Excel, you can sort of delete the rest of this data. I would make sure that you have a backup of the original text file because there are serial numbers and things in here that are useful. But you can delete that, and then you can scroll down to the bottom, hitting Control down, and just delete that text at the bottom of the file. It's kind of annoying that they put it there, but they do. So again, Control, and this time I'm going to hold Shift and up, and that will then select all of the data. So that was Control, Shift, and the up arrow key. And then I will say text to columns, fixed width, and Excel will do a pretty good job of figuring out where it needs to go. You can remove this one if you wish. I'm going to remove it just to make the next step a little bit more complicated because your data might be like this. So I'm just going to drag this black arrow or double click this black arrow so that, I'm going to keep it, sorry, to make the next step slightly more complicated. But you could remove it to make the next step slightly more simple. So I'll click Finish, and then I'll scroll up to the top and I'll add a new row. And so this is the date, time, pressure, so the centimeters of water, and temperature in degrees Celsius. So let's just explore this for a few minutes. So this is saying May 26 at 0:100. So this is just the way Excel is displaying this. You can actually see here it's actually 9 a.m. So you can actually just change the format of the numbers. So now it thinks it's 38 cents, and we can actually just change it to time. So it's just displaying the data different ways. And the important point to note is that if entered correctly, these are all just numbers. So noon, as we'll see if we convert to a number, noon is half a day or 0.5 days. And 42,881 is 42,881 days since January 1st, 1900. And so this is relevant, or to understand how Excel deals with dates, for a couple of reasons, which will become more apparent next. But then we can change these back to their original formatting. So while you may think that says 9 a.m., it actually is entered into Excel as 0.38 or 0.38 of a day, or the 9th hour divided by 24 hours in a day. 0.375, 0.375. So we can just change this back to a time. The next thing we need to do now is go to our manual data that have been entered. And we'll see here we have date, month, site, the in measurement, the out minus the in. And again, this is where I was talking about with the times earlier. So if time are entered in military time, 1355, then in order to combine the time and the date, we would say equals the date plus the time divided by 2400, because it assumes that there's 2400 sort of hours or minutes, if you will, in a day. Whereas if we've entered our time correctly using colon, sort of 13 colon 55, which Excel will convert to different formats, then we can just take our raw date and add the time to it. So what we'll see here is that our full date in the wrong column is 42,880.56, which is the equivalent of 1355 divided by 2400, whereas here it's 42880.58, which is actually the correct decimal of this time. The reason this works closely but not perfectly is because it assumes that each hour has 100 minutes, and so 13.55 is assuming that it's 55/100ths of the 13th hour, which is why we get off by a little bit as you get closer to the whole hour. If this was a whole hour, such as 1300, then the times would be identical. So depending on how your data are entered, and I just happen to know by scrolling down that they were entered incorrectly, or they were entered with military time, that we'll be using this I column. If you do have time, then you should go through and fix the data, basically converting this to a correct time. So again, Excel will just manipulate it for you, which is annoying. And then you'll have to update your equation, because then this won't make much sense to Excel. So again, I'll put it back in the old format of 1355, but then change it to a number. So this is quite annoying about Excel, but this is just sort of the way times work. So this is kind of a long preamble to a fairly simple task. But so once this is done, you can double click in the lower right hand corner, and as long as it has something to drag down against, then you can pull that equation down with you. Now I made up that time, and I made up these columns, so I will delete that. So now I'm going to hit Control and Shift and highlight all of the data and create a pivot table. And click OK into a new sheet. And I'm going to drag the full date wrong as my row labels, in as the sum of my values, out as the sum of my values, and my out minus in. And then I'm going to create a report filter based on the site. And so I'm going to drag the site into here. I'm going to select, I'm going to say select multiple items, uncheck all, and I'm going to scroll down to the well that I happen to know corresponds with where this data logger was installed, and that is in Northeast 2, or that was the well North East 2, and click OK. So what should happen is that all of your numbers should change to 1, because basically saying on this day we took the measurement of the in once, the out once, and then this calculation of out minus in once. If you have multiples in here, if you have 2, it either means you measured the same well at the same time at the same day, or you've entered something incorrectly. So these should all read 1. You can now right click and click average. Right click, value field settings, average. Right click, value field settings, average. And now sort of be done with this. We can then copy this and paste it into our data from the data logger over here, so that we have our manual data. So what I want to do now is try to match my manual data with the actual data that we collected. With the pressure transducer data. So basically, what I want to go through, and I want to see on day 42,880, which we can convert to a long date. So on May 25th, 2017, what did the pressure transducer record? Well, what you can already see is that we actually installed the pressure transducers the next day. So we're actually more interested in this date here. So June 15th. 2017 at 0.64 of a day. So if you are really interested in being able to see everything all at once, you can come in here and you can say more number formats, click on custom, and then you can actually say month, 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 day, day, year, 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 hour, hour, minute, minute, like this. And you can make up that date format so that it shows up as you want it. So June 15th, 2017. But you actually don't need to worry about any of this. You can actually just leave them as numbers. I was just kind of teaching about that. So here I'm going to insert a new column, and this is what I was saying at the beginning of the video, that if you left these together, you don't need to do this step. But I like to just re-emphasize this, is that you can say this equals this plus this, because Excel is looking at this as a number and this as a number and combining them together to create a number. So despite the fact that it's just showing it in this format, which is, again, quite annoying, we can see that the dates are pretty close. And of course, as I said, we were 1 day ahead of installing the data loggers, which is why these are 881 and we started at 880. So what I need to do now is just do a VLOOKUP equals VLOOKUP, and I'm going to look up this value, comma, in this table. So holding Shift over, and then Control and down to highlight all of my data. From the second column, I want to pull the information, that's the pressure column, and I want an approximate match, and I'll explain that in a minute. So what we see is we get a not applicable, and that's because there's no 42880 in here. But if I changed this to 42880, I would get a number. So it's basically saying, look in these 2 column or 3 columns of data, look for this value, and tell me what the pressure is. So 42880 has a pressure of 0.525, meaning that it wasn't installed, it wasn't underwater yet. So if I change this back to what it's supposed to be, we'll get the not applicable again. I'll just add some dollar signs around the green box. Realistically, because you're not dragging down that far, you don't actually need them, but it's best practice to do it correctly. And then we can drag it down. So now we've seen that on 42901 at 0.64 that the pressure was 90.75, 94.75, and so on and so forth. Now you'll notice that these dates are coded as 00, meaning that it was on midnight that day. I highly doubt that you were out at midnight that day. So in the absence of any other information, noon is going to get you closer to the actual value of what was there. But really, you should go through and check your field book and go back into the manual data for that day and figure out the best time, and then redo this step so that you don't have midnight measurements. So now what I can do is I can highlight the in and the pressure transducer data, and I can create an XY scatter plot where I can right click and add a trend line with a display with the equation and R squared value. So we have a reasonably good relationship, and you'll see that this is a little sensitive. If I change this back to 0, then our relationship actually gets a little bit better. But you know, I just don't know if I believe that this is correct. Now, if you showed up first thing in the morning, took measurements, and then it rained at 11 a.m., then maybe noon isn't the best surrogate, right? So maybe we put this in at 0.25, so 6 a.m., right? This is why you should always be writing down your time that you measure a well that has a pressure transducer in it. So I'm just going to assume for now that 6 a.m. is the correct time, but just do make sure that you go back and check your raw data. You check your field books, see what other times you wrote down, and make it as best as possible. So now that we have this equation, which is y equals mx plus b, or in here y equals minus mx plus b, and we're just going to solve this equation for x, which will basically be x equals y, which is the pressure, minus b, which is 99.917, and then divide by m, which is minus 1.165. So all I've done is rearrange this equation and solved for x, and this is the equation. That's how that equation is solved. So when I hit enter and I pull down, we'll see that we're starting to get values that kind of make sense. So this is the calibrated in measurement. So if you were at the well and you measured in, this is what it would be. We could do this analysis on the out minus in and come up with a relationship. So we could add a trend line, and we could redo the whole thing where we now actually have depth below surface, because this is the out minus the in, and then we would just change, so we would redo the same equation with the out minus in. So it kind of depends on what you're really interested in. Are you interested in getting the in if you were there? And then you can either average the outs for the season, because there's quite a bit of variability in these outs and you don't have a lot of trend through time. I actually think maybe taking an average out would be a better course of action. But if you have lots of field data and you can see what the out is doing, then you're probably in better shape. So that's basically the end of this video. We now have a column of data that has corrected the data logger pressure transducer data to our field measurement. So this is the calibrated in. And so if we assumed that the out the whole summer was an average of 10.4, then we could say equals 10.4 minus each of these values and drag it down, and then have our calibrated out minus in. Or put another way, depth below surface, where positive numbers are above the water surface. You'll see a few wonky measurements at the beginning. You'll need to delete these because they were prior to the data logger being installed. And actually, if we highlight all of the data, you'll also see some wonky measurements towards the end, because this was when it was pulled out of the field but then sat in the lab for the weekend before being dumped. So you'll need to kind of go through and scroll through here. You can usually tell based on the temperature and things. It went from 10 degrees to 18 degrees over the course of an hour. This is probably when it was pulled out of the field without checking the notebooks. And I can just delete that and get rid of those data, so that now when we plot our data, bring this back up to the top. Now that we plot our data and we have depth below surface, this is now what the water level did during the summer as depth below surface.